We now get to practice these different concepts that we've learned in the last 3 videos. We need to determine whether A is positive or negative, determine the vertex, axis of symmetry, and range. In part 1, or part A, we have a parabola opening upwards with a vertex in the first quadrant. We can list the vertex value, which is at coordinate point 3, 1. The axis of symmetry is at x equals 3. And we can see the parabola is opening upwards. If it's opening upwards, we know A is positive or greater than 0. We can say A is greater than 0. We can say our axis of symmetry, and I'm just going to abbreviate that AOS, is x equals 3. We need to determine the vertex, which we did. Vertex is at 3, 1, and the range is from the minimum upwards. You always go from the vertex toward the direction the function is opening. So we include the minimum, which is at 1 in the y direction, and it approaches in the range positive infinity, since the function is opening upwards. Now let's look at part B. Part B is a parabola with vertex in the second quadrant, opening downward. This parabola has a vertex at -2, 2. Its value for A is less than 0. This is because the parabola is opening downward. Its axis of symmetry is x equals -2. And we can draw that axis of symmetry right down the center of the parabola. Now we need to look at the range. The range is from a maximum of 2 to negative infinity. Now, you might be tempted to put the function in like this. I see this all the time. But remember that you always write your range from small to large. So remember to put your range in as the smallest value, which in this case would be negative infinity, to a maximum at 2. And since the maximum is a vertex, you include the endpoint, so it is a closed bracket. Let's practice some more, but this time we will also be graphing. The graph of the function f of x equals the quantity x minus 5 squared plus 2 means we will have a vertex at 5, 2. It opens upward. And this is because A is greater than 0. Its axis of symmetry is always the first value in the vertex, so x equals 5. And the maximum or minimum value will be the height at which the vertex is, y equals 2. Let's go ahead and graph this. We have a vertex at 5 and up 2, over 5 and up 2 from the origin. We know that it opens upwards. And we know that it has the standard shape of a standard parabola. It's just been shifted horizontally and vertically. So I have to use the standard shape of a parabola, which is from the vertex over 1 up 1, and then over 2 up 4, which is what happens when you square a number. When you square 1, you get 1. When you square 2, you get 4. That's how I'm counting the points for completing the vertex and the parabolic shape. Next, I have g of x is equal to negative the quantity x minus 2 squared minus 4. The vertex, we know, is the opposite of h, so 2, and the shift up or down. In this case, it's been shifted down 4. So negative 4 is the vertex coordinate point. Since we have a negative sign in front of the function g of x, we know that a is less than 0. So it opens down. The axis of symmetry is always the value of x at the vertex, so x equals 2. And we know that the function is opening down, so it will have a maximum at negative 4. Previously, when we had a positive value for a, we had a minimum value at y equals 2. Now let's go ahead and graph this. First, I'm going to start with the vertex at 2, negative 4. From here, I know that the function is opening downwards. So this is my parabola opening downwards. And my axis of symmetry for both of these, I can draw it. I don't have to, but my axis of symmetry is at x equals 5 on the first example and x equals 2 on the second example.